The GBU-43/B Massive Ordnance Air Blast, MOAB, nicknamed Mother of All Bombs, is a large-yield, non-nuclear bomb developed by the United States military. Overview. Type, guided bomb, thermobaric weapon. Developer, Air Force Research Laboratory, AFRL, United States. Manufacturer, McAllister Army Ammunition Plant, Oklahoma. First tested, March 11, 2003. Entered service, 2003. Unit cost, approximately $16 million per unit, estimated. Primary user, United States Air Force. The MOAB is designed to destroy large areas, such as cave complexes, tunnel networks, or fortified positions, through a massive blast wave and intense heat. It is a thermobaric weapon, meaning it uses oxygen from the surrounding air to generate a high-temperature explosion, creating a prolonged and devastating blast effect. Design and specifications. Weight, 21,600 pounds, 9,800 kilograms. Length, 30 feet 1.7 inches, 9.1885 meters. Diameter, 40.5 inches, 1.03 meters. Explosive fill, 18,700 pounds, 8,500 kilograms, of H6 explosive. H6 is a highly stable explosive mixture composed of RDX, TNT, and aluminum powder, providing 1.35 times the blast power of TNT. Blast yield, equivalent to approximately 11 tons of TNT. Guidance system, GPS/INS, inertial navigation system, with a KMU-593/B guidance kit. Delivery platform, MC-130E/H Combat Talon I/2, Special Operations Cargo Aircraft. Deployment method, dropped from the rear ramp of the aircraft using a drogue parachute to stabilize and slow descent, allowing the aircraft to escape the blast radius. The MOAB is too large to be carried by standard bombers like the B-52 or B-2 and requires a modified C-130 transport aircraft for delivery. Its size and weight make it one of the largest non-nuclear bombs ever developed. Purpose and capabilities. Primary targets, soft to medium-hard targets, including cave and tunnel complexes, massed personnel or light vehicles, fortified structures in open terrain. Blast effects. Creates a massive pressure wave that can collapse structures, destroy equipment, and kill or incapacitate personnel over a wide area. The thermobaric effect consumes oxygen, creating a vacuum that can suffocate individuals in enclosed spaces and cause severe internal injuries, e.g., ruptured lungs or organs. Effective radius depends on terrain and target type but is estimated to be up to 1 mile, 1.6 kilometers, for significant damage. Psychological impact. The MOAB's sheer destructive power and visibility serve as a psychological weapon, intended to demoralize enemy forces and demonstrate military capability. Limitations. Ineffective against deeply buried or heavily reinforced targets, e.g., bunkers. Requires air superiority and minimal anti-air defenses due to the slow, vulnerable delivery method. Large size restricts deployment flexibility. Development history. Origin. The MOAB was developed as a replacement for the Blue 82/B Daisy Cutter, a 15,000-pound bomb used in Vietnam and the Gulf War for clearing jungle landing zones and attacking troop concentrations. Project timeline. Initiated in 2002 during the early phases of the global war on terror to address the need for a weapon capable of destroying cave networks used by Al-Qaeda and Taliban forces in Afghanistan. First test conducted on March 11, 2003, at Eglin Air Force Base, Florida. Second test on November 21, 2003, confirmed operational readiness. Design team, led by the Air Force Research Laboratory, with contributions from Dynetics, Guidance System, and other contractors. Production. A small number of MOABs were produced, estimated 15 to 20 units, with at least one deployed to the Middle East as a deterrent. Operational use. Only known combat use, April 13, 2017, in Nangarhar Province, Afghanistan. Target, Islamic State Khorasan Province, ISIS-K, tunnel complex in the Achin district. Delivery, dropped by an MC-130 aircraft operated by U.S. Air Force Special Operations Command. Outcome. The U.S. military reported 94 ISIS-K militants killed, with no civilian casualties, though local reports were mixed and unverifiable. The strike destroyed a network of tunnels and caves used by ISIS-K for staging attacks. The operation was described as a tactical success but sparked debate about the strategic necessity and cost of using such a weapon. Other deployments, MOABs have been pre-positioned in the Middle East, e.g., Diego Garcia or Qatar, as a deterrent, particularly against Iran and North Korea, but no other combat uses have been documented. Controversies and criticism. Cost versus effectiveness. Critics argue the MOAB's $16 million price tag is disproportionate to its tactical utility, especially compared to precision-guided munitions or smaller bombs. Civilian risk. The massive blast radius raises concerns about collateral damage, particularly in populated areas, though the 2017 strike was in a remote region. Strategic value. Some analysts view the MOAB's use as more symbolic than militarily necessary, intended to send a message to adversaries like North Korea or Iran during a period of heightened tensions in 2017. Environmental impact. The explosion can cause significant ecological disruption, though specific data on the 2017 strike's environmental effects is limited. Comparison to other weapons. Versus Blue 82 Daisy Cutter. The MOAB is larger, more powerful, and GPS-guided, making it more precise and versatile than its predecessor. Versus Nuclear weapons. The MOAB's yield, 11 tons TNT equivalent, is orders of magnitude smaller than even the smallest tactical nuclear weapons, e.g., 0.3 to 1 kiloton. It is explicitly designed as a conventional alternative to nuclear options. Versus Russian FOAB. Russia claims to have developed the father of all bombs, ATBIP, a thermobaric weapon with a reported yield of 44 tons TNT equivalent. However, details about the FOAB are unverified, and Western analysts question its existence or capabilities. Cultural impact. The MOAB's nickname, Mother of All Bombs, coined by the military, has entered popular culture as a symbol of overwhelming destructive power. Its use in 2017 garnered significant media attention, with footage of test explosions widely circulated. The weapon has been referenced in discussions about U.S. military strategy and non-nuclear deterrence. Current status. As of 2025, the MOAB remains in the U.S. arsenal, though no additional combat uses have been reported since 2017. The exact number of units in inventory is classified, but production appears limited due to the weapon's specialized role. Advances in precision-guided munitions and bunker-busting bombs, e.g., GBU-43 massive ordnance penetrator, may reduce reliance on the MOAB for future operations. Additional notes. The MOAB is often misunderstood as the largest non-nuclear bomb ever used in combat, but its primary significance lies in its thermobaric design and psychological impact. Public information is based on declassified U.S. military reports, open-source analysis, and media coverage. Some details, e.g., exact inventory or guidance system specifics, remain classified.